this example here. Find the resultant moment of force on the beam below. Now we're going to have a diagram drawn. Have a beam being drawn here, and it is pivoted at that point. And then we have a downward force of 12 newtons, which is a distance of 3 meters from the turning point. We have another force on the other side, which is 4.5 newtons and a distance of 5 meters from the turning point. And that is the turning point. We have another force on the left. We have 10 newtons and another force on the right upwards, acting upwards, which is 6 newtons. And this force of 10 newtons is at a distance of 4 meters, and this force of 6 newtons is at the distance of 2 meters. Now here you can see that we have these 4 forces acting at different points on the same beam, and therefore what they will have their own moments on this beam. Each of these forces has its moment. So what will be the resultant moment? The resultant moment will be a single moment, which will be representing or equal to 2 or more of these forces acting on the same body, as we are going to look at it in this example. So we shall say that we need to get the sum of clockwise moments. We have to identify which of these forces will give the body a clockwise direction, will make the body to turn in a clockwise direction. Then we put them together. That's why we're calling it the sum of clockwise moment. Now, looking at this force of 10 newtons, this force of 10 newtons will make this beam to turn in a clockwise direction. So what is its moment from the turning point? So its moment will be 10 times 4. Now plus which other force? When you look at this one, can this make the body turn in a clockwise? No, this one will be anti-clockwise. How about this one? Yes. Okay, so we have this one will make this to turn in clockwise. So we add it. So I have 4.5 times the distance, which is 5. Okay, 4.5 times the distance, which is 5. So when we find the sum of clockwise moments, we shall have 40 plus 22.5, giving us 62.5 Newton meter. Which direction is this? It's clockwise direction. Then we go. Now we are left with 2 forces, 12 and 6. So implying that the 12 is anti-clockwise and the 6 is anti-clockwise. So we look at the sum of anti-clockwise. The sum of anti-clockwise, which is the 12, making this beam to turn in this direction. So we shall say 12 times 3, and also this one turning in this direction makes it 6 times 2. 6 times a force times the distance from the fixed point. It's the distance from the fixed point. So we shall have 36 plus 12, and we get 48. Now we have the sum of clockwise giving us 62.5. The sum of anti-clockwise moments got 48. Now which moment is greater than the other? You can see that the clockwise moment is greater than the anti-clockwise moment. So the resultant, we shall say the sum of the clockwise minus the sum of the anti-clockwise moment, giving us 62.5 minus 48, and we get 14.5 Newton meter. Now because the clockwise moment is greater, the total effect or the final effect will be the clockwise direction, to be in the clockwise direction. So we have 14.5 Newton meters in the clockwise direction. Good. That is an example to find the resultant moment of force. Okay. Okay, let's look at example 2. Find the resultant moment of force on the beam below. Again, we draw our beam, and we're going to have the number of forces acting on the same beam. Now the beam is pivoted at that point with a force of 12 newtons acting downwards, a distance of 3 meters. A force of 10 newtons acting downwards, a distance of 1.5. Okay, then we have another force which is 8 newtons acting upwards on the left, and another force of 20 newtons acting upwards but on the right. Now these forces, the 8 is 6 meters from the pivot, and this one of 20 newtons is 4 meters from the turning point. So here you can see that there are 4 forces again, but acting at different points in different directions. Each of these forces will provide or will give a moment of force. So what will be a single force which is equivalent to the number of these moments on the same beam? So we now look at the solution. We draw our diagram again and indicate the directions of the moment of force. It is pivoted at that point, 12 newtons, 3 meters, and the one of 10 newtons, 1.5 downwards. Okay, then you have the one of 8 newtons and the one of 20 newtons acting upwards. This is a distance of 6 meters and the distance of 4 meters. So now these forces, we must first identify their directions. They will turn this beam so that we know the clockwise moment and the anti-clockwise moment. Okay, and a force of 8 newtons will make it to turn in this direction, giving us a clockwise direction. Then we have this 20 newtons will make it to turn in this direction. And which direction is this? Anti-clockwise. 12 newtons making it to turn into anti-clockwise, and lastly 10 newtons making it to turn into a clockwise direction. So the 8 and the 10 newtons give clockwise direction, and the 12 and the 20 newton force give anti-clockwise direction. Having known their distances and the directions of moments, we can now say that what is the sum of clockwise moment. The sum of clockwise moment, as we have seen, the 8 and the 10 were clockwise, giving is 8 times 6, because 6 is the distance of the 8 newton force from the pivot. So we say 8 times 6 plus 10 times 1.5. So we have 48 plus 15, giving us 63 Newton meters. And which direction is this? It is a clockwise direction. Okay, how about the sum of anti-clockwise moments, which we shall have the 12? We remained with the 12, which is 12 times 3 plus 20 times 4, giving us 36 plus 8. 36 plus 8 giving us 116. But which direction? We have the anti-clockwise direction. So we now look at the sum of clockwise and the sum of anti-clockwise. Which one is greater? You can see that the anti-clockwise moment is greater than the clockwise. So we shall get our resultant moment to be the sum of anti-clockwise minus the sum of the clockwise moment. Substituting, we get 116 minus 63, giving us 53 Newton meters as the resultant moment. But which direction will it turn? You can say, since the anti-clockwise is greater than the clockwise, so it is in the anti-clockwise direction, and that is the resultant moment, anti-clockwise direction. So dear student, we shall end here, and next time we shall now look at the principle of moments. But please ensure that you do the exercise that we give, and if you have not enrolled for this program, please you can call the numbers below your screen to see that you are enrolled, such that you do not watch these tutorials like you're watching a movie, but you can be evaluated, you can be marked, you can be given exercises, and therefore you evaluate yourself and know that you are understanding this